All right, let's get right into it. Think about this. You are constantly surrounded by threats. We're talking bacteria, viruses, all kinds of microscopic invaders just trying to set up shop. So how are we not sick all the time? Well, it's because we have this incredibly sophisticated built-in defense network that works 24/7. And today, we're going to break down exactly how that network, your immune system, fights back. I love this quote because it just nails it. Your immune system isn't some passive brick wall. No. It's an active, intelligent security team. It's constantly patrolling, it's adapting, and this is the amazing part, it's learning. And that intelligence is exactly what makes it so powerful. So where does this all begin? Well, every great fortress needs its walls, right? Before any kind of cell-to-cell combat even happens, your body has these incredible, always-on barriers designed to just keep the bad guys out in the first place. This is your first line of defense. And these aren't just simple walls, they're incredibly clever. Your skin is this amazing physical shield. The mucous membranes in your nose and throat, they're basically sticky traps. If an invader gets swallowed, well, it has to deal with a vat of stomach acid. Even your tears and your saliva have enzymes that destroy bacteria on contact. And, a simple cough is literally your body physically throwing invaders out. That's the big question, isn't it? Because no wall is perfect. A cut, a virus you breathe in, some particularly nasty bacteria, things can get through. So what happens then? What happens when the alarm bells start ringing? This is where your innate immune system kicks in. You can think of these guys as the body's first responders, the patrol officers who are always on duty. They're programmed to act fast, and they react to any sign of a breach almost instantly. And this right here is maybe the most important thing to get your head around. Your immune system has this two-part strategy. You've got the innate response, which is all about one thing, speed. It's a general, blunt force attack on any foreign invader. But, and this is key, it has zero memory. The adaptive system, on the other hand, that's your specialist. It's slower, yeah, but it creates a custom-tailored attack for one specific pathogen, and it remembers that enemy forever. So who are these first responders? Well, first you've got the eating cells, or phagocytes. These are the ground troops. They just go around literally engulfing and digesting invaders. They're amazing. Then you have natural killer cells, or NK cells. They're kind of like the internal police, looking for your own body's cells that have gone rogue, like they've been infected by a virus. And then there's the complement system, which is this cascade of proteins that can either punch holes in bacteria or, and this is cool, paint a target on them so the phagocytes can find them more easily. You know that feeling when you get a cut and it gets all red, swollen, and warm? We've all been there. Well, that inflammation isn't the problem. It's actually the solution in action. It's the visible sign of your innate system at war. Damaged cells release chemical alarms, which make the local blood vessels expand and get a little leaky. This lets all those phagocytes we just talked about rush out of the bloodstream and swarm the area to fight the invaders. All that extra fluid and all those cells are what cause the swelling and heat. It's a battleground. But sometimes, the initial wave just isn't enough. The pathogen might be too strong, too fast, or there are just too many of them. The first responders are getting overwhelmed. They need to get on the radio and call for backup. They need the specialists. And that is the cue for the adaptive immune system. This is the elite, special ops branch of your body's defenses. Now, it takes longer to get going. We're talking days, not minutes, but its response is incredibly precise, it's powerful, and it leaves behind a permanent legacy. Okay, before we meet these specialists, we have to understand what they're looking for. They're hunting for things called antigens. The easiest way to think of an antigen is like a unique name tag or a molecular fingerprint on the surface of a pathogen. It's the specific face of the enemy that the adaptive system learns to recognize and hunt down. The adaptive team has two star players, B cells and T cells. B cells are like tiny weapons factories, pumping out these highly specific proteins called antibodies. You can think of them as smart missiles that only lock on to one specific antigen. Then you have the T cells, and they have a couple of jobs. The helper T cells are the generals, the battlefield commanders. They coordinate the entire attack. And then you have the cytotoxic T cells. These are the assassins. Their job is to hunt down and eliminate any of your own body cells that have been hijacked by a virus. All right, the elite team is on the scene, so what kind of firepower are they bringing? This is not a one-size-fits-all situation. The arsenal they use is incredibly specialized and diverse. What's so cool is that not all antibodies are the same. It's like having a whole toolkit for different jobs. You've got your first responder, IgM, which shows up early. Then you have the long-term workhorse, IgG, which provides the bulk of the protection. You even have specialized guardians like IgA that hang out in your gut and your lungs to stop infections before they can even start. It's an amazing system. So how do these little protein missiles actually win the fight? Well, they have three main tactics. The first is neutralization. They just swarm a virus, completely coating it so it physically can't attach to your cells. The second is opsonization, which is my favorite. They basically tag an invader, slapping a giant "eat me" sign on it so those phagocytes can easily find and destroy it. And third, they can trigger that complement system we talked about, starting a chain reaction that kills bacteria directly. Okay, so antibodies are fantastic for taking care of threats that are floating around in your body. But what about the enemies that are already inside the gates? What about the viruses that have already infected your cells and are using them as virus-making factories? Well, that's where the assassins come in, the cytotoxic T cells. They can spot an infected cell from the outside and they will destroy it, sacrificing one of your own cells to prevent thousands of new viruses from being released. It's a tough job, but it's absolutely crucial. And this, to me, is where it all gets truly mind-blowing. The adaptive immune system doesn't just win the war and go home. No, it creates a detailed file on the enemy. It learns. It builds a memory so that if that same bad guy ever dares to show its face again, the welcome party will be swift and devastating. This timeline just shows it perfectly. The very first time you get sick with something new, your adaptive system is slow to respond. It takes days, even weeks, to build up its forces. You feel sick. But the second time? Oh, it is a completely different story. The moment that pathogen shows up again, the memory cells are activated, and the response is so massive and so fast that the invasion is crushed, often before you even feel a single symptom. And that powerful, incredible memory, that right there is the entire principle behind how vaccines work. A vaccine is basically a safe training exercise for your immune system. It introduces a harmless part of a pathogen, or a weakened version of it, which lets your body go through all the steps of building a full-scale memory, all without the risk of you ever getting sick. It's like giving your army the enemy's playbook before the battle even starts. So, from fortified walls to first responders to an elite team of learning assassins, the immune system is nothing short of a masterpiece of defense. Its entire job relies on one critical skill: telling the difference between you and not you. But what happens when that system makes a mistake? What happens when this brilliant defender turns on the very body it's supposed to protect?